Okay, so now we're going to break down all the different curves that show up in this perfect competition graph one by one. So like, don't let me have me break this thing down for nothing. I want to see y'all in your raddest behavior, okay? Typically, when I'm in class teaching this, I would just go down the line. I would ask them a question, they would reply. I'd ask them a question, they would reply. Uh, so you're basically alone. You're watching this at your house, presumably. So you're gonna have to do this yourself. But let's, without further ado, let's do this. All right. Okay. So we're gonna break down this last graph. This guy here. We're gonna draw the marginal revenue, marginal cost, average total cost, average variable cost for an individual firm in a perfectly competitive industry. Okay. All right. So that's the goal. Okay. What starts on the x-axis? Quantity. Right. Okay. We're going to keep the y-axis blank because it's going to be both cost and revenue. You could write dollar signs if you want, if that's how you measure your cost. That's a pretty standard way to measure cost, but I'm just going to leave it blank, and we're going to let the curves be what they are. Like the marginal revenue curve equals marginal revenue. Okay. So what shape is marginal revenue? This is where you answer at your house. Marginal revenue should be shaped like a Nike curve. Oh, excuse me. Nope, that's the one that's not. Marginal revenue, because firms are price takers, should be perfectly elastic. Okay, which means it's going to be a straight horizontal line. Boom. Okay, so that's your marginal revenue. What is marginal revenue equal to? Okay, so if I give you a relationship where marginal revenue equals something for a firm in perfect competition, what would you say it is? Y'all should be saying it's equal to your price. Okay, so your P star from the industry problem should be like a normal supply and demand function. Oh, sorry. A normal supply and demand function is going to be the firm's marginal revenue. It's going to be the firm's demand curve. They don't really have any say in price. They are price takers with perfectly elastic demand. Okay, if they raise their price even a little bit, they're just going to sell nothing. Okay. What shape do marginal cost, average total cost, and average variable cost look like? If you said fishing hook, if you said Nike shaped, you'd be correct. They're like a little swoosh. Okay. Like a little hook. Okay. Draw the marginal cost curve. So we're just going to presume that there's one given marginal cost. So it's going to be shaped like a Nike swoosh. So we're just going to draw that. Boom. There's your swoosh. Okay. Where are the average total cost and average variable cost minimized? Okay. So fixed cost is a constant, right? Your marginal cost, I don't know why I said that actually doesn't matter for this. Your marginal cost is essentially going to be the cost of producing the next additional unit. So remember when I was talking about you have your midterm grades, or sorry, you have your grades at day 30 in the semester, and you start getting grades that are above it. Well, that raises your average. You start getting grades that are below it, that drops your average. So your marginal cost is basically like your next grade. So if you're plotting an average total cost and a marginal cost, if your marginal cost goes above your average total cost, that's going to be increasing your grade. If your marginal cost goes below your average total cost, it's going to be decreasing your grade. Okay. So let's say we have average total cost looking like this. Well, it's going to be minimized at the point where marginal cost is no longer below the average total cost. So average total cost starts higher, okay, and it's being dragged down by the marginal cost until it's not, and then it's being dragged up by the marginal cost. Okay, so once marginal cost starts dragging it up, that's the minimum. Okay, and then the same thing with average variable cost, because average variable cost is just a constant fixed cost plus your, average total cost is just the constant fixed cost plus your average variable cost. So they're both behaving in the same exact way. Okay, so the average total cost and average variable cost are minimized at the point where they intersect with marginal cost. Boom. Oh, JK. So here's your average total cost. Is your average variable cost above or below average total cost? Well, what is average variable cost? It's your variable cost divided by your quantity. What's your average total cost? It's going to be your variable cost plus your fixed cost divided by your quantity. Okay. So average total cost is more unless your fixed costs are negative for some reason, which doesn't make any sense. So average total cost is going to be higher. Okay. And like I said, notice that as Q goes to infinity, these two will start to equal each other. Okay, they start out pretty far apart, and then the further down the x-axis you go, the closer they become together. Okay. Where is the optimal quantity Q star? Q star is anywhere that marginal cost is equal to marginal revenue. So if I'm doing like a hot and cold, I'm going to go right to this point right here where marginal cost equals marginal revenue. And down here is your Q star. Okay. So this is your equilibrium for the firm, Q star, P star. Okie dokie. All right, so before I get there, no, let's just do it. How low would price and marginal revenue have to be until firms stop entering? Okay, so basically, what's the break-even price? Break-even price is when price equals average total cost. Is it here? No. Why isn't it there? Because if price drops to here, right, quantity is going to be here, not here. Okay, so even though this is an intersection between average total cost, it's not going to be where the optimal quantity is, right? You have to keep in mind that the optimal quantity will be decreasing as price decreases. So if I bring it down here, is this? If I bring it down here, is this? Break-even price? No, because at this point, even though marginal revenue intersects with marginal cost, like if I'm driving this curve down, it's going to be higher than your average total cost. Okay, the intersection will be where all three intersect. So this is your break-even price when marginal revenue intersects with marginal cost, intersects with your average total cost. Okay. So your new price would have to be down here. Okay. And then same thing with the shutdown price. That's how far a firm will have to go before how far price will have to go before a firm stops producing. So that'll be the intersection between your average variable cost, your marginal cost, and your marginal revenue. So that'll be down here when your marginal revenue drops down here. Okay. So that's your shutdown price. Okay. So if marginal revenue suddenly drops down here, no firms enter. If marginal revenue suddenly drops down here, firms will want to leave. Okay. Yeah, let's stop there. That's